All right, here's some synthesis problems. And so they're going to be focused on the alcohol chapter. So we are going to bring in some of our new alcohol reactions. And what am I doing here? I've got the same carbon chain, so I'm not going to add or subtract any carbons, but it does look like I am going to do some sort of substitution where I take that OH group and I substitute it with a bromine. It also looks like it was a SN2 reaction because if you see that, the stereochemistry has reversed. Now, alcohol is not a great leaving group. So in order to make it a great leaving group, I have some options. One thing I could do would be to react it with acid, but if I react it with acid, I'll just end up eliminating it instead. So another way to turn it into a good leaving group would be to turn it into a tosylate ester by reacting it with TSCl and pyridine. Now that I've done that, I've turned this alcohol into an OTS. And now that it's an OTS, I can easily react it with something like sodium bromide. And then to promote the SN2, I can add DMSO as a polar aprotic solvent in order to, again, promote that SN2 reaction at the secondary position. So that's a efficient synthesis for that particular reaction. Okay, what's going on with this next one? It looks like I am going to add some carbons. 1, 2, 3, 4, 5, 6, 7, 8. I've got 9 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like I've got to add 4 extra carbons. Oh, I'm sorry. 3 extra carbons. Let me do the math right. All right, so how do I do that? Well, I'm going to need some sort of carbon-carbon bond forming reaction. One thing I can do is alkylation, but I'm going to have a little problem with alkylation, possibly because I'm going to end up with an alcohol group. Now let's see if we can do that with some Grignard reagents. But I guess I'll need to form a Grignard reagent first. And one of the things that I could do to form a Grignard reagent would be to turn the reactant into alkyl halide. Well, let's think backwards though. So if this was going to be my Grignard reaction, then I guess I would have needed to react it with a 3-carbon carbonyl group if I'm going to turn this into an alkyl halide. So if I'm going to do HBr and ROOR, then I'll turn it into the anti-Markovnikov alkyl halide. And then I can react this 1, 2 with the 3-carbon alkyl, 3-carbon carbonyl group, 1, 2, 3, and I would form the alcohol at the end by adding water. Now, I don't think it's possible that it can be done with alkylation. It might just take a little bit more time to do that. Okay, let's see what's next. I've got 1, 2, 3, 4, 5, 6, 7 carbons there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons there. So it does look like I need to add some serious carbons. Now, how could I do this? I'm going to add some carbons, but the other thing to look at is that I'm adding carbons to this location, but it looks like I have to add them in a branched fashion. So there's not a way that I could add a carbon chain at a secondary position. What I need to do is maybe some successive Grignard reactions. And so let's take a look. If I were to react something like this with methyl Grignard and water, I would get that product. Well, what do I need to do now? What if I had then something that I can get this carbonyl group with. Let's see. If I had an alcohol group there, then I could do an oxidation reaction in order to accomplish the formation of that carbonyl group. What's next? What if, in order to get that alcohol group, then maybe I had another carbonyl group here, and this was my first 1, 2, 3 carbons. My first Grignard reagent. So I need 3 carbons, so it's propyl, Mg, Br, and water. Then I think I can get here as long as I do oxidation, but I can't do sodium dichromate. I have to do PCC and pyridine in order to stop the oxidation at the carbonyl group. In this oxidation step, I could have used either one because I've got a secondary position. And so the oxidation would stop at the carbonyl no matter what. Okay, so I think I solved it.